We've been talking about harmonics, and specifically about the harmonic series. Just to recap, the series consists of a fundamental pitch, also known as the first harmonic, and a series of whole number multiples of the fundamental. So, if the fundamental is 100 Hz, for example, then the series is made up of 100, 200, 300, 400 Hz, and so on. And I said that these harmonics are what is largely responsible for the tone of the signal. All good on paper, but how does it sound? To demonstrate, I've put together a special synthesizer. This gizmo generates sine waves, which we said are the most simple form of oscillation, in integral or whole number multiples of the fundamental. What's more, the sine wave generators in this synth can track pitch through MIDI so that we can play different notes in the harmonic series where any particular pitch will remain intact. So if you play an A 2 octaves below middle C, which has a fundamental or first harmonic of 110 Hz, then the series would go 1 times 110, 2 times 110, 3 times 110, etc., resulting in sine waves at 110, 220, 330, 440, and so on. If, however, we were to play a C 1 octave below middle C, which has a fundamental of 261.63 Hz, then the series would look like 261.63, 2 times 523.26, 3 times 784.89, 4 times 1004. Oh, you get the idea. So, here is what each harmonic sounds like individually, starting at C. I've used just the first 8 harmonics for this example, but it's enough to illustrate the idea that the harmonics are related to the fundamental in some musical way. What I mean is that the ratio between the first 2 harmonics is 2 to 1. That is, the frequency of the second harmonic is double that of the first. We know from previous videos that that means that the second harmonic is an octave higher than the first. Now the ratio between the second harmonic and the third is 3 to 2, because the second harmonic is 2 times the fundamental, and the third is 3 times the fundamental. This 3 to 2 ratio sounds like the musical interval of a fifth. The next interval is a ratio of 4 to 3, which sounds like a musical fourth. The fourth harmonic is also double the second, which is an octave, and 4 times the fundamental, which sounds like 2 octaves. So the ratio between harmonics sound like musical intervals. Here's an illustration of the musical intervals of the first 8 harmonics in notation. And here is a chart showing the same information in ratios relative to the fundamental. Here's what the harmonics sound like all together. And here is that sound played as a C major scale. Interesting, but not that useful. But by adding the various harmonically related sine waves together in different proportion, I can manipulate the tone into something far more musical. And remember, these are just harmonically related sine waves. Cool, huh?